Hello and welcome. Enrichment series summation, and this is the series that we're trying to sum. Definite pattern. We got fractions being added on the top. We got 10, 7, 4, 1, minus 2, minus 5, and at the bottom we go ascending factorials, 1 factorial, 2 factorial, and so on forever. So what's the sum to infinity of this particular series? Okay, with something like that, as I have said before, with series in general, if they give it to you in sigma notation, write a few terms explicitly. If they give you the series explicitly, write in sigma notation. Sometimes you can actually see better things from one version or the other. So the first thing I'm going to do, I'm going to say, okay, this is the same as sigma from, let's say, r is equal to, we'll sum it from r is equal to 1 to infinity, and on the numerator, in order to get a linear, an arithmetic sequence that goes down starting with 10, it's got to start with 13 minus 3r. So when we put r is equal to 1, should give us 10, 7, and so on. And on the denominator, we go simply factorials. Okay, so that's essentially the same as that. And we try to think now, what can we do in order to get the sum to infinity for this? Often with series of this sort, it's best to actually look for other well-known series, such as power expansions of exponentials, arc sines, arc causes, the log of 1 plus x, the factorials that we got in there without any gaps, because of course sine and cos will be having gaps in there, is telling us something perhaps with exponentials might be suitable for this one. And in the sigma notation, we've got one advantage there. We can actually split the fraction here. So the first thing that I'm going to do is I'm going to say, let's split this using the linearity of the sigma operator. And we can actually say, shall I move the 13 also at the front? I probably will. So 13, 1 over r factorial. So that's the 13 over r factorial, minus, I'm going to put the particulars on the sigma in a second. Let's put the 3 on the outside, and we got sigma, and we're going to have r over r factorial. Both sigmas, of course, run from r is equal to 1 to infinity. All right, so far so good. And things which look like this, oh well, they're the exponential, and the e. So let's write somewhere on the side here what is e. E from the standard exponential expansion is in fact 1 plus 1 plus 1 over 2 factorial plus 1 over 3 factorial, and so on forever, which in compact notation it's exactly the same as sigma. Unfortunately, we have to run it from r is equal to 0 here. So let's write it from r is equal to 0 to infinity, 1 over r factorial. So that's exactly the same thing. Keep in mind that the 0 factorial is in fact 1. So that's 1 over 1. Then the 1 factorial is also 1. So that's going to give us the first two terms. And after that, it's kind of obvious pattern. So something which looks like that is something to do with e quite clearly. It's not quite e, because our summation starts from 1 and we're missing one term. So I'm going to do a couple of things at once. This is enrichment, so you should be able to follow if I miss a few steps or do too many steps perhaps at once. So look what I'm going to do. There's the 13 that I have at the front. I'm going to put a big square bracket, and I'm going to add 1 to this sigma from r is equal to 1 to infinity of 1 over r factorial. So that is, of course, that. I added 1, and of course, I'm going to subtract 1 to balance it. So that's exactly the same as this, quite clearly. And what I'm going to do with this one, well, it makes sense, and I hope we can all see this, that we can actually cancel top and bottom and r. If we have r over r factorial, the r factorials, of course, are r minus 1, r minus 2, and so on, 4, 3, 2, 1. And of course, if we cancel the leading r, we're going to be left with 1 over r minus 1 factorial. So this will be happening once I cancel an r, top and bottom of the summand. So this is going to become 1 over r minus 1 factorial. Okay, this is interesting. Let's see what we're getting from this line here. First of all, why did I add this 1 in here? It's because this particular power series that I've got here, up to here, this quantity here, is in fact just this part of the series. If I add 1 to it, I can make an E out of it. So this now will become 13 square bracket. This I can write it in sigma notation now. Is from r is equal to 0 to infinity of 1 over r factorial. That is now the sigma plus the 1 I've just added minus a 1. Okay, and what happens to this one? Okay, if we look at what terms we're getting, I mean, what is this now? And let's look at the terms we're actually generating. I'm going to write it up here from this particular power series. I claim that this is in fact E. We can actually write it. I'm going to write it and then we can check it perhaps. I'm going to shift the dummy index, the r, into 0 to infinity and change that into 1 over r factorial. If you cannot follow quite that why that is, let me just generate a few terms from this sigma just to actually see what we're getting. R is equal to 1, we're getting 0 factorial. So we're going to get 1 over 0 factorial plus r is equal to 2. 2 minus 1 is of course 1 factorial. 3, 1 over 2 factorial, and so on. So this is the terms that are being produced by this sigma, which of course are 1 plus 1 plus 1 over 2 factorial plus 1 over 3 factorial plus dot dot dot. So in fact, this, I don't even need to rewrite it, I mean we should be able to see it, is in fact just E. And all I've done in here, I shifted r into r plus 1, so this became now an r factorial and my summation started with 0. It's exactly the same terms. So this bit here generates these terms and so does this one as well. So the game is done now. You say that's it. There's nothing else to do there. Just put our bits in. 13 bracket, and what do we have? This sigma is of course my E minus 1, and then I go minus 3E. If we tidy this up, we're going to get 13E minus 3E. Let's write it perhaps in a different color pen for the answer. And the answer to that will be 13E, 10E altogether. And from that, we got to subtract 13. The exact answer of the sum to infinity of what I've written originally up on the board up here, this converges to 10E minus 13. I hope you liked it. I hope you enjoyed it. Who's laughing now?